And then cosine is negative. Cosine's the x-coordinate, so we have to be over there, right? So I can eliminate this. So I can draw a triangle that looks like this. Remember, our reference triangle always goes back to the x-axis. Starting here, out, up. Which side of that triangle do I know? The hypotenuse is root 5. And the adjacent side is -1. And then we can solve for this side. So this squared plus this squared equals this squared. Should just be 2? -2. So remember what I'm doing there is I'm saying -1 squared plus some other side that I don't know. I'll call it, it's the y-coordinate, y squared equals root 5 squared. Right, that's what I'm doing. This side squared plus something squared equals that squared. And then that's y squared equals plus 1 equals 5. And then subtract 1 and then take square root. I get either plus or minus 2. But because I'm down on the y-coordinate, it's -2. So sine is this side over this side. So what is it? -2 over root 5. And that's it. That's what we need. You ready? Sine of alpha plus beta will be sine alpha cosine beta plus sine beta cosine alpha. That's the formula. Equals, what is sine of alpha? 4 over 5. Times cosine beta, -1 over root 5, right? Plus sine beta, which is, where is it? Oh, here it is, right there. -2 over root 5 times cosine beta, which is -1 over root 5. Wait a minute, hold on. I messed that up. This is supposed to be what right here? Alpha. This is supposed to be alpha right here. Y'all see that? Alpha right there. Cosine alpha was -3 over 5. All right. Everyone see where that comes from? Now multiply your fractions straight across. So -4 over 5 root 5 plus 6 over 5 root 5 equals 2 over 5 root 5. They both had the same denominator, right? This one is going to be cosine alpha cosine beta plus sine alpha sine beta. Cosine alpha cosine beta plus sine alpha sine beta, which is -3 over 5 times cosine beta, which is -1 over root 5, plus sine of alpha, which is 4/5, times sine beta, which is -2 over root 5. Any questions on where all that comes from in here? Did I get it right? Does it look right to you? Three over 5 root 5 minus 8 over 5 root 5, which is -5 over 5 root 5, and you can cancel out, so -1 over root 5. What do y'all think?
It's a lot of complex stuff.
It's look kind of complicated.
What's the point of this again?
Yeah, that's a good question. All right. And you're not going to like this, but I'm going to put it on the board. Maybe you will like it. You didn't like him on the test. Show cosine of alpha minus beta over sine alpha sine beta equals cotangent alpha cotangent beta plus 1. That's an identity. We must show it's true. So how do we handle these things? Start with one side and make it turn into the other. And I'd say that maybe start with the left because, well, we've just been covering this formula, haven't we? So we know what cosine of alpha minus beta turns into. Let's go ahead and write that down. Cosine of alpha minus beta, so I'm starting with the left-hand side, is cosine alpha cosine beta plus sine alpha sine beta. Right? We proved that one actually using circles, that is that. Over sine alpha sine beta. That's actually good news. These are the same, aren't they? Now you can't just cancel them like this though, because you have two numerators, you have a single denominator, right? You can split this into two fractions and then cancel, but you can't just cancel it like this right here. Does it make sense why you can't do that?
Yeah.
Let's make sure it makes sense. What's 7 plus 4 over 4? Can I cancel these 4s and make that 7? No, that's what you would be doing here if you tried canceling these right here. What you could do here is split it up into 7/4 plus 4 over 4. That you can do. And then it becomes a 1 here, and then here it's 7/4. All right, that's allowed. So that's what I'm going to do here. I'm going to split this into two. We're going to go cosine alpha cosine beta over sine alpha sine beta plus sine alpha sine beta over the same thing, sine alpha sine beta. That's a 1, right?
Yeah.
That's a 1.
Yeah.
And this one, cosine over sine. Cosine of alpha over sine of alpha is cotangent alpha. Cosine beta over sine beta is cotangent beta. So this is cotangent alpha cotangent beta plus 1. Check. You ready for two more formulas? No? We have two more. I wonder what tangent of alpha plus beta is. Well, what is the definition of tangent? Sine over cosine? So wouldn't this be equal to sine of alpha plus beta over cosine of alpha plus beta? I mean, isn't that the definition of what it is? And don't I have formulas for both of those? The numerator is sine alpha cosine beta plus sine beta cosine alpha over cosine alpha cosine beta plus minus what? What is this one? Minus, okay, sine alpha sine beta. Yeah, that is a formula, but it's not the one that the book will use. The book has something different. So I'm going to try and get to the books. No? Don't do it. Just give you the formula? Do you want me to derive it, or do you want me to just give you what this can algebraically be simplified to? Come on, speak up. It's your education, it's your life. What do you want?
Just the formula?
Just the formula? Okay, that's fine with me. Tangent alpha, this turns out to be tangent alpha plus tangent beta. Oh, that's not a beta. Over 1 minus tangent alpha times tangent beta. That's the formula in the book for this.
And we need to memorize that?
No, I wouldn't memorize that. The other two I would start to put into the memory banks. And here's why. Here's why I would not really care to memorize that. And there's another one, okay? But the way I'm going to show you the other one, let's see if you pick up at all on what I said earlier. If I change this to a minus, this becomes a minus, and this becomes a plus. Does that make sense? These formulas are on page 648. So if you have a plus here, it'll be plus and then minus. If you have a minus here, it'll be minus and a plus. Now here's why I wouldn't necessarily ever really need this formula, because let's say someone wanted to know what tangent of, let's say, pi over 12 was. That was that one we did earlier, right? Didn't we do sine of pi over 12 or cosine of pi over 12? Yeah? If I were doing this, what I would do is I would just split this up to be sine of pi over 12 over cosine of pi over 12. And then each of those, I would just do those. I would just do the actual formulas. You know, like split it up into two different things and just go across with them. I actually wouldn't use this formula. I very rarely use it. Have had to use it. But there's where they are. That's what they are. All right. Different topic. Same section. We have now a total, I've given you a total of 8 formulas. We have the cosine, sum and difference for cosine, sum and difference for sine, those 2 formulas that you did by yourselves, and then the 2 formulas for tangent. Example. Find exact value of sine of arc cosine of 1/2 minus arc sine of 4/5. That look messy? It should look messy. So squint your eyes a little bit. Just kind of squint your eyes, step back. And see if you can see that you've got sine of alpha minus beta here. You all see sine of alpha minus beta? Yeah? What is the formula for sine of alpha minus beta?
That is sine alpha.
Okay, so hold on. Sine alpha. So I need to write here sine of cosine inverse of 1/2, right? That's sine alpha times cosine beta. So times cosine of beta, but beta is really arc sine of 4/5. Okay, so I have sine alpha cosine beta, then minus sine beta. What's sine beta?
I thought it was cosine alpha. It's sine, right? Alpha beta.
I said, well, the way I presented it to you is sine alpha cosine beta minus sine beta cosine alpha. It's the same thing. The book does it backwards.
Okay.
Okay. I do sine. So sine what here? Sine of beta, which is sine inverse of 4/5. Then times cosine of cosine inverse of 1/2. Does that look terrible or what? But do you see it? Do you see how this is just sine of alpha minus beta, rewritten? Now, what's great about this, even though it doesn't look that great, is what is this? That's just 4/5. Because you have sine, arc sine, they wipe each other out. So you just have 4/5 here. Now, it's 4/5 as long as this number in here is smaller than 1, which it is, or between -1 and 1. And then what about cosine of arc cosine? That's just 1/2. So these last two are pretty straightforward, aren't they? That's the good news. The bad news is that each one of these individually is a problem that I've given you in the past. You have to look at them by themselves. This right here should return to you, without the sign, arc cosine of 1/2 is an angle, isn't it? And it is the angle that corresponds to an x-coordinate of 1/2, right? And it's got to be within the restrictions of cosine. So this is something we can figure out and then take sine of it. And then this one over here, reference triangle. So you see these two problems are actually just things we've done. So let's do those. The other parts were easy. All right, I'm gonna do this one right now. I'm gonna do it over here. I'll come back and stick the answer in here. When I'm doing sine of arc cosine of 1/2, the way I did in class, I said this right here is an angle theta, and then that means that theta is arc cosine of 1/2, and that means that cosine theta is 1/2, but you can only live where with arc cosine? Top 2. So where's your x-coordinate? 1/2. Pi over 3. That's right up here. Good. Y'all are getting faster than I am. That's good. That's what you want. Theta's pi over 3, right? And now you come back in here, right? This was sine of theta. So this is really sine of pi over 3. And now you're at the same angle, right? But the y-coordinate, which is root 3 over 2. So that means this right here is root 3 over 2. Times, now for this one, it's not a common, 4/5 is not a common value. So we're actually going to need the triangle for this. Can I erase that over there? Okay. So I'm going to do cosine of arcsine of 4/5. Cosine of arcsine of 4/5. Did I mention that I really like this problem? No. I didn't mention that, did I? I really like this problem. It's a good test problem. Because it does illustrate a lot of understanding, doesn't it? You've got the formula, sine alpha minus beta, you can manipulate that. And then within it, you've got a lot of different things that we've talked about. Yeah, you can go back to the unit circle, or in this case, we're going to have to do the reference triangle. So here, call that alpha, call that theta. Theta is arcsine of 4/5. So that means sine theta is 4/5. So long as we are where? The right side, right? So we're going to be in the first quadrant. So that's the only time your sine, your y-coordinate can be positive. So reference like this. Opposite over hypotenuse, 4 and then 5 here, which means the adjacent is 3, positive 3. Because this really wants to know what's cosine of theta. And that's going to be 3/5, isn't it? Yeah. Okay. This is one of those classes, pre-cal, where you can't just like shed off in like a couple of sections and still survive. Like you have to have it all together. You know what I'm saying? Like if you're still having trouble, like where's pi over 3? Like it's obvious that this is going to get harder and harder for you to hold on, right? Look, remember, I don't make this up, okay? I'm just the messenger, right? I'm just here to help deliver the message. Oh, wow. We've got common denominators, right? Yeah. Good. It normally works out that way, okay? So this one's going to be right across the top because I'm multiplying. 3 root 3 over 10. And then I have minus 8 over 10. I'm not going to reduce this fraction because I'm going to put them together. 3 root 3 minus 8 over 10.
Is that 4 over 10?
What is what?
4 over 10.
Where? Where are you talking about? This?
Yeah.
I had 4. Yes? That's it. That's the exact value of that expression. Man, this section is brutal. Brutal. This is going to look somewhat familiar. Write as an algebraic expression. I'm about to give you an expression that has trig functions in it, and at the end, you're not going to have any trig functions anymore. Here we go. Cosine of arcsine of u minus arc cosine. Do I want to use u again? I don't really. Well, I'm gonna push it here. U plus 1. When you're done, you should have no trig stuff at all. Purely algebraic stuff. Squared, square roots, things like that. So what do y'all see? What formula? Okay, so what cosine of alpha minus beta? Do y'all see it? Cosine, here's alpha, here's beta. Do y'all see how we can rewrite that as cosine alpha minus beta? All right, let's just write that out. This will be cosine alpha, but alpha is sine inverse of u. Okay, then cosine beta. What's beta? Cosine inverse of u plus 1. It's very much like the last problem, isn't it? Except I don't have exact values in here. So then what? Minus? Plus, right? Because it's cosine, it's opposite. So this is plus. Now sine alpha, sine beta. So sine of arc sine of u times sine of cosine inverse of u plus 1. Oh, wow. I just had a really nice moment there. I was thinking about what's for dinner. And then I remembered that I put something in the crock pot this morning. That's a great feeling. Knowing that when you get home, you're going to have food. Isn't that, maybe y'all are. Or is anyone else at that crock pot phase of their life yet? No? You're not there yet? Trust me, when you get there, you'll love it. All right, it's hard to mess up a crock pot. You can throw pretty much anything in there, season it up, leave it for 8 hours, come back. It's going to be at least moist. You can be guaranteed that. Yeah, yeah. Okay. I'm sorry. It'd be nice if there was like a little bubble above my head during lecture. Y'all would probably just freak out. Yeah, the stuff that goes, because I think some of the times I'm just like on autopilot up here, just kind of like going, and I'm thinking about other things. And
from math straight to food, back to math.
I think it was never math. I think it was always food the whole time. All right, I'm giving you time to like think through this. What's the good stuff here?
Aren't they all like reference triangles?
Are they all referenced though?
Well, sine u and arc
Sine,
sine
arc
u.
sine.
Yeah, two of these are good, right?
Yeah.
Two of these are good. This one right here
This is u plus
should just be u plus 1. I'm going to put in parentheses because it's going to have to get multiplied by whatever's out here. And this one right here is a good one, u. I'll put the plus between them. That'll be a multiplication. So there's two that I have to still go work with, don't I? And I'm going to have to do references on those. All right, let's take care of this first one right here. Cosine of arc sine of u. So we call this piece here theta. That means theta is arc sine of u, which means that sine theta is u. So call that thing your angle. There it is. Take sine on both sides. Make sure we're restricting ourselves into these quadrants. Now you don't know if u is positive or negative here, do you? You don't. You don't know. So when you create your reference triangle, it doesn't matter which quadrant you go into, all right? I'm going to use this right here. U is the u over 1, right? This is the same as u over 1. So opposite over hypotenuse, u over 1 like that, then what is this side here? It's the square root of 1 minus u squared. See, and that's why it doesn't matter if you use u positive or negative, because when you square it, it doesn't matter. Okay? 1 minus u squared here. So cosine is going to be the adjacent over this. Yeah, because we want cosine. Yes? So this right here is cosine theta, but according to my triangle, it's this over 1, which is just the square root of 1 minus u squared. So that goes here. Almost there. Got to get that last one. I think for the last one, I'll do it right below it here. I call this thing right here theta. Theta is arc cosine of u plus 1, which means that cosine theta is u plus 1. And then I try and create a triangle again. I have to be in the top 2 quadrants. So again, doesn't matter which way I draw it, so I'm going to draw it here again. And how do I do this? It's the adjacent side, right? U plus 1 is this side right here. U plus 1. And this is 1. So this is a little tricky. I'm going to do this one a little bit slower. We're interested in that y coordinate, aren't we, off that triangle? So it's like 1y, u plus 1. So if I do Pythagorean, I have u plus 1 squared plus y squared equals 1 squared. And if I solve that for y squared equals 1 squared. 1 squared is 1. Minus u plus 1 squared. So I just move that to the other side. And then square root, right? When I square root, that's it. It's ugly, but that's what it is, right? So this side is square root of 1 minus u plus 1 squared. Pardon? Oh, fun. Yes. No, I agree. I agree. That's this last part right here. And that's it. We'll just leave it like that. It's an algebraic expression, right? We have no more trig functions in there. I think this is a good stopping point. I think you've had enough, because we're not done with the section. The next thing we're going to do in this section is solving trig equations, which is what the last section was about. But now we get to use these formulas to help us solve trig equations. Is that okay? We stop now? Yeah. Okay, for your homework, and I also need you to sign in. For your homework, let me just see how far you can go. You can do all of your homework. They don't do any the homework assignment doesn't have any solving equations on it, which is just wrong, but we'll do some solving equations. All right. Let's start it right here. Please sign in, then you can go.